I use the function moment. It's used to find the contours, and then I found the box where we put the list. So that's all for the task. Next, just I found that using find homography and then word perspective, I found the transformation matrix and applied it. And there I put how I found Z numbers. Yes, probably it's a bit tricky. I think I just calculated there because I already have detected corners. I found the maximum from X and my minimum from X and maximum from Y, minimum from Y. So, and it was a size which I put there. Then I use it for that thing. So then, yes, it's a final. Yes, there is. I implement some function called called filter by literal blobs. So that's why I think if I delete that function, you will have a bit another picture, but it helps with that no other lines. So that's all. And I don't know how to do that find answer function. I think that's just all. That's all.
So have you used half transform here?
Yes, you can see. Yes, half transform, how we can use it. Firstly, we need to convert to grayscale. Then we need to use scanning detector to detect edges. Then I used filter by little blobs. I think without filter by little blobs, it also works well. And then I apply half lines. And I played a bit with parameters there. I think it's no need for that parameters on that one. So, and then I just draw the lines. Yes, because you using that lines, that half lines, I found the half lines, and I found the rho and theta for that lines, for each lines, and then I just how to say, draw the lines on my picture. That's all.
So the next step would have been easy for you because, but then in the thresholded image, all the marked answers are not visible. So you might not be able to detect all the answers or responses, I think. So that is one thing. And so you can select each line, which is, for example, which is vertical. And then those line one by one, you can consider from the leftmost side to the rightmost side. And this you can check using your line equation, and you can check
okay.
the for example, if it is the row has to be increasing for the leftmost to the rightmost, so you can select one by one and
check if there is any yes, okay,
and similarly you can do the same because the y-intercept, y is equal to mx plus c, if you consider like that, the c value will be increasing in a uniform way for the horizontal lines. And so like that, you can go across each horizontal and vertical line, and one by one you can check whether there is any marking between these limits. So that is one possible way of doing it. But to get all the marked answers, you have to get all the responses also visible in the thresholded image. So that is the next thing.
Okay. So I can stop my sharing.
Yeah, you can.
Okay.
So
Should I
Yuri, you can.
should I share? Do you see that? Mm, Do you see my screen? Mm, Do you see my screen? Okay.
What are you looking for, Yuri?
Okay. So the task was to detect faces on the image.
Your voice is not clear.
Uh, mm. Okay, here we are using cascade classifier. It takes as an input this path to file, which is like pre-trained file. Yeah. Um, and then we're just using detect multiscale, which means it constructs a pyramid of scaled images and then applies features. And it returns a list of bounding boxes. And for every bounding box, we write in it. We are drawing it, something like that. For cats, it's the same, but we are using different weights, pre-trained file. It's for cat face. Here we had for like human face. Then we just zip faces of people and cats, and for every pair in this zipped list, we just swap him, something like that. With neural net, it's kind of the same. You have this DNN. Actually, we are reading it from disk. It's just like a bunch of weights and stuff. And also we are converting our image into the blob. It's a format that can be accepted by the net, feeding it to our net. And again, we have like a list of bounding boxes, confidences, and things like that. If our confidence is greater than 0.5, we say, okay, this is the face, and we are drawing it here. And see, result is kind of similar. For face detection in video, we are just doing it frame by frame. So it's just our like hard cascade classifier, and to just calling this function for every frame, and that's it. I've added this debug print to have like an idea what's going on and what's the progress. And let me show the video if I can find it here. Yeah, should be this. Oops, probably not this one. With this. Oops. No. Um, so
You
yeah,
saved it as it is output
yeah, but
Y. output y.avi.
Well, let me just stop share for now and try to find this file because I've downloaded it. Oh yeah, it should be. Yeah, okay. Mhm. Mm, I am back. I am back. Here's the file. So as you see, it's kinda not ideal because it doesn't see this guy. Oop. Now sees a lot of false positives and false negatives as well, but it kind of works. So yeah, that's about it.
Okay, thank you, Yuri and Katya, for the presentations. So, uh, so we have achieved a kind of a milestone by completing a presentation, whatever we have scheduled for the whole block for this course, especially for our lab. So, so that is uh, I thank all of you for presenting. So for participating in this presentation also. So next, uh, today's session, if you have listened to today's lecture, that was related to object tracking. So the lab session also will discuss about object tracking. In OpenCV, there is already existing object tracking algorithms which are implemented. For example, go turn, which is discussed in your lecture, that is already implemented in OpenCV. And other than that, there are many other conventional tracking algorithms. So you can look out for the OpenCV documentation and you can see different tracking algorithms. So in today's session, we'll be using OpenCV, and then towards the final part of it, second part of it, we'll be using TensorFlow based implementation also using SST. So that is a different CNN uh, uh, different tracker, which is also quite famous. So, so just as we had seen from Yuri's presentation, or for face detection session, for object tracking, what we do is first we decide a particular region of the image which has to be tracked, and in the uh, so videos are made using multiple images which are stacked together. So that is called, each of these video images are called as frames. So at one frame, you detect the object region to be tracked. And in the consecutive other frames, that position of the object is determined using the tracker. So we have two sets of videos. One set of video is with a person moving a red ball around. So uh, once we detect the location on the red board, if you are continuing to track it using OpenCV based algorithms, you can track the position of the ball which is visible in the first frame or the frame where it is visible. And there is uh, standard functions which are already used for this particular case. Let me show the video which is so the a red object is being shown, and then you find a circular region which which will approximate the red object, and then after given the red object uh, uh, bounding box, you can use OpenCV based tracker to track the whole uh, object across the whole frame. So first we have some few functions. This is to detect the red object and to draw a bounding box over it. And then while you use OpenCV trackers, so you have multiple options of trackers. So you have to decide one of the trackers and then you can use them. So, so to initialize, you have to initialize which tracker you are going to use. So that you have to initialize first. So this function initializes the tracker to be used. And the task which you have is to detect this region, this object in the video, and then continue to track it using the OpenCV based function. So first what you will do is initialize the tracker using the functions above. So you have the functions here. So you initialize the tracker here. And once you initialize, uh, uh, you can see the documentation for OpenCV for information about the trackers, how to initialize it. So already you have the function to initialize it. And uh, next task which you will do is, once you initialize it, you have to supply uh, uh, bounding box for the frame which has where the object has been found, and the consecutive frames you have to track. So what you will do is, first you will detect the red object and find the bounding box for the red colored object. And after that, the consecutive frames you supply to the tracker, and you will be able to track the uh, object in those video or the frames of the video. So what you will do is, first you will uh, keep on checking whether you have obtained the red object, and then once the bounding box is obtained, the rest of the frames, that is each of the images from the frames, you will supply to the tracker, and then you will get the bounding box from the tracker if the tracking is successful. If the in that case, you can draw the bounding box on the frame, and then you can uh, write back the uh, frame into an output video, and then finally it can be saved. So this is for basic structure of opening a video. So this you would have already done if you have implemented the face tracking section, the task. So you capture the video, or so actually you can either capture it from your webcam or from the path where you have the image. So once you capture the image, you take one by one each of the frames, and then in each frame you will detect a red object, and then you will draw a bounding box, and the consecutive frames you will be drawing the bounding box if it is detected on the same frame, and then it is saved back as the same an output video. So the output video will be saved using this uh, uh, function video writer. So at uh, each frame which you have detected, you will write to the out object, and then you can at the end when you just release the video, the output video will be saved. So the video which you will use for implementing this tracking will be the video video file which is shown in this line, so which you have already loaded at the first stage. So this is uh, object tracking using the already existing OpenCV based function. So you can vary different kinds of trackers and then see the results, how it will be varying. And then you can see the output, how it is different also. So you also have go turn here. So even you can use that also, and you can use different other functions. So this is one thing. Uh, and the next task which you can do is to uh, uh, to track objects using SSD. So so here we are using PyTorch based implementation. So not the PyTorch. You have a PyTorch based version also of SSD, but we are using uh, the implementation which is shown here, TensorFlow based implementation which is shown here. And so first you will load the image, and for each frame you can check for the object which is to be tracked. So in this case, you will be using a video with multiple cars. So so this video, you can track multiple cars using this video, and when you detect the cars, you can write it back. So this is the next task which you will be doing. So the basics, some of the skeleton is already present. So you will be looking for the object car. First, you will detect the car object. Once you detect the car object, you can continue to track. So, so that is how this is implemented. So this is also the task which you can run. Yeah. So similar to whatever you have done, the same way you will be doing in the tracking in this case also, and then you can get an output video with the regions where you have detected the object. So similar to what you are done, so you can uh, detect each at each frame the object, and then after that you can write it back to the output video, same as what you have done earlier. So this is about tracking using the already existing OpenCV based function, and then SSD based uh, detection and tracking. So, this is much pretty much about this today's lab session. So if you need to ask something, you can ask me. Otherwise, I can discuss about some of the other parts of the course. So do you have anything to ask right now? So if there is no specific thing to ask, so as I mentioned, today is the last session for the lab. So those material which you have covered from the lab would be important for your final exam. So especially the task which you're supposed to do in the lab session. So if you are able to solve those tasks, then only you will be able to uh, uh, attempt or complete the lab exam which you will have towards the end of the course. So this is one thing. In the next lab session, as well as the lecture session, we will be having only presentations. So each of the student group will present their project, and we will not have regular lecture as well as lab session in the next week as well as the week after that, or not the week, the next day, that is Thursday, as well as Monday, we will have only presentations of project where each group will be presenting their final achievements and highlights of the project. So that is one thing. The schedule for this presentation will be communicated to you, will be the schedule will be made and it will be communicated to you at a later stage. So so this is about the coming sessions. And apart from that, today is the deadline for the lab for the project final submission for group 2. So so you please have a look at the deadline and make those submissions so that you will not be late and you will be on time. So that is about the major milestones or important aspects of today and the sessions which is coming in the future. So do you have anything, any specific query to ask at this point?
So next week we will have the projects presentation, and week after we will have final exam, right?
The next session for a lecture as well as lab will be completely converted to presentation. The same will be true for Monday's lecture and lab session. The exam will be after that. So
exam will be next week or in a week after the next one.
So as per the information I have got, it should be on 12th of October. So that will be it will not be next week, the week after the next. So this is a tentative date. So if there is any change, that will be announced in the next sessions, that is on Thursday or Monday. I think this has been announced also in your Moodle announcements. Let me check if there is any update. No, so I think it will be, if there is any difference, that will be announced. So tentative date will be 12, but it may be, it uh, might be with the Department of Education. If they have some concerns or issues, then that will be changed. So so you can get a final uh, date for the exam, might be by Monday or even before that. So and another thing is, for the presentation, project presentations, everyone has to present, and even group 1 as well as group 2, both the groups have to present for the final presentation. So be prepared to make that presentation, even if your project is complete or not. Whatever is complete, whatever is you have done, that has to be presented in the final presentation. So individual lab check, the individual demonstration or check will happen for group 2 after the presentation. So after most likely after Monday, we will schedule time for the demonstration of, or checking for the group 2 students. So group 1, I think only Katya is there in group 1. You for your presentation, the schedule and information you can discuss with the professor. So he will give a better idea about how the demonstration will happen. So do you have any other clarification other than this? So I'm also updating today's attendance for all of you. For only difference was Yuri has joined, otherwise it remains the same. So if there is no specific question, so I especially wish you all the best for your final presentation and exams. And in between, if you have some concerns or issues, you can write to me. I'll try my level best to answer it. And I also want to thank you for specifically showing so much interest in attending and presenting your work also. And your other grades and stuff will be communicated in the future as they are ready. So that is So with all of these information, we can wind up today's official session, and I will stay online for you. I will be available for you if you want to ask me any specific queries, and till 12:10 I will be available. You can write to me if you have any specific queries regarding today's session. So you should also be even till today's session, should be completely careful about whatever exercises has been done. So, and the submission dates for the Thursday session, I have uploaded the submission link for the Thursday session, last Thursday session. So for today's also, as well as last Thursdays, I am assuming that I have extended the deadline. So you will have 1 week for submission. For last Thursdays, you will have to submit this Thursday. And today's lab session task, you can submit on Monday, which is in the coming Monday. So that means that you will have 1 more week to complete this task. So please work on these exercises so that it will help you to prepare for your final lab exam also. So with this, I am winding up the whole session. Thank you for today, and bye.
Bye. Thank you.
Bye.